All right, so this is the video where we're going to be talking about doing stoichiometry, where we're given the amounts of two different reactants. So remember in our last one, we said that if we're only given the amount of one of the reactants, we assume we have plenty or excess of the other one. So here's a case where it says I have 27 grams of hydrogen and 120 grams of nitrogen. How many grams of NH3 can I make? Well, what we need to do if we're doing this in the stoichiometry method way, and there's going to be another video where I'm going to show you another method. What we're going to do is we're going to take each reactant, and what we're going to do is we're going to take each reactant and we're going to solve for the amount of product it would be able to make. So let's go ahead and do this, and then I'll talk about what we're going to do with it. So if we have 27.0 grams of hydrogen, this is what we did in our last video. We know that 2.02 grams of hydrogen is equivalent to 1 mole of hydrogen. Because remember, to do stoichiometry, we need to know how many moles of a reactant we have. For every 3 moles of hydrogen, I know I can make 2 moles of ammonia. So this is my 3-to-2 ratio here. That's my stoichiometry. And if I want to convert moles of ammonia into grams of ammonia, I go ahead and get the molar mass from the periodic table. And this says I can make 152 grams of ammonia. Now again, this assumes I have excess nitrogen. But I don't necessarily have excess nitrogen. So let's do a second stoichiometry problem where we have 120.0 grams of nitrogen. So that's our second reactant. And we're going to do the same kind of process, but this time I need to convert my mass of nitrogen into moles of nitrogen. And in this problem, I'm going to look at the coefficient here for the nitrogen. 1 mole of nitrogen gives me 2 moles of ammonia. So this is our stoich. This is using the coefficients from the balanced equation. And if I want to convert my moles of ammonia into grams of ammonia, very similar process. And this says I can make 146 grams of ammonia. This assumes there is excess of my hydrogen. Well, how am I supposed to know how much I can make there? Well, notice if I use up every itty bitty gram of that nitrogen, I make 140 grams of ammonia. I don't have any more nitrogen after I do this, so that means I can't make any more than 146 grams of it. Now notice I have enough hydrogen where I could actually make all the way up to 152 grams. Will I be able to make that? No, I actually can't make that amount because as soon as I make my 146 grams of ammonia, I'm actually going to run out of the nitrogen. I don't have any more nitrogen to make any more than that. So this is the mass of ammonia that I can make, and it's the nitrogen that is limiting me to only being able to make 146 grams of ammonia instead of 152 grams of ammonia. So the nitrogen is what is referred to as the limiting reactant. By definition, the limiting reactant runs out. I don't have any left of it. It's all going to be used up to make that 146 grams of NH3. But what that means then is I'm going to have some leftover hydrogen. So this is what is referred to as the excess reactant. There will be some left over. So what we do is we take each one of our reactants and we solve for the product. And the lower of the two product amounts is what can be made. So the lower of these two amounts is 146 grams of ammonia. That means I can't make 152 grams of ammonia. That means I'm going to have some leftover hydrogen. Vocabulary words. Limiting reactant means it runs out completely. Excess reactant means I'm going to have some left over. All right. I wonder how much I'm going to have left over. Hey, I bet that'd be a great question to ask. So now my question is going to be, well, how many grams of the excess reactant remain? Okay, so I know in this case my excess reactant is hydrogen. Now I know I'm going to use up some of it. I wonder how much I'm going to use. Well, you know what? If I know I'm using up all of the limiting reactant, so if I start here with my limiting reactant amount, 120.0 grams of nitrogen is, remember, I'm using that up completely. If I go ahead and I convert that into moles of nitrogen, according to my balanced equation, for every 3 moles of hydrogen that I use, I also need to use 1 mole of nitrogen. So I'm relating to the quantities of 2 different substances in the chemical equation. So this says for every 1 mole of nitrogen, I need to use 3 moles of hydrogen. So this is the stoichiometry, okay? And then every 1 mole of hydrogen has a mass of 2.02 grams of hydrogen. So if we go ahead and we do the math on this one, this means that 25.95 grams of hydrogen are used to react with 120.0 grams of nitrogen. So that's what that means here. This many grams of nitrogen needs this many grams of hydrogen to react because of the coefficients in our balanced equation. We know for every 3 moles of hydrogen, we need 1 mole of nitrogen. Okay? So, but that's not the question I asked. I asked how many grams of the excess reactant remain or are left over. Well, let's see. If I know how much I started with, and if I know how much was used, I think if I subtract those two, I think I'm going to know how much is left over. So let's see. According to the problem, we started with 27.0 grams of hydrogen. The math here told me, the stoichiometry told me 27.95 grams of hydrogen were used up. So how much is going to be left over? The difference in those two values. And so this is going to be, if I subtract this, this is 1.05. Oh, shoot. Wait a minute. This one goes to the 10th place. This one goes to the 100th place. So I guess I need to round this to 1.1 grams of hydrogen are going to remain. So whenever we have a problem where we have 2 different amounts of reactants, we refer to that as limiting reactant, excess reactant stoichiometry. We take each one of our reactants and convert it to the amount of product we can make. We then take the lesser of the 2. That's the amount that we actually will be able to make. And we know whichever reactant gave us that amount is the reactant that's going to run out, or it's the limiting reactant.